This is everything supplied with the kit. I've assembled the board and all the components on it. I have not assembled the LM713. I've not assembled the NMOS device. There's 2 potentiometers, 2 washers, 2 nuts, 3 LEDs, red, green, and yellow, 2 insulation pads to fit this device, 2 screws, and earlier I had 2 of these insulating washers. They're actually to fit on. The device goes on top of the insulation pad. The little round insulating washer goes there, and the screw holds the whole thing together. Now, that doesn't explain what the screw screws into. So I'm going to supply a heat sink. I'm going to supply a second heat sink, much smaller, and I'm going to mount the LM317 on it. I've decided not to insulate it from the heat sink. Just put a drop of heatsink conductive heat paste on this sink and fasten it securely with one of the screws. For testing, I'm going to use this transformer, which will furnish 24 volts AC. Now this transformer is a 115 by 24 transformer. I'm going to adjust the output using the adjustable voltage transformer to 15 volts. I hope to install the whole thing in this case, which is 8 inches by something. In addition to these components, I'll furnish some banana jacks, an on-off switch, a volt ammeter, probably a 12 volt switching converter and a little board, and maybe 2 of these relays. You want to know what the relays are for? Stick around. So this will be the test setup I use to power the power supply kit. For testing purposes only, I'm going to use this variable transformer. I have a white cord plugged into it and then hooked to the primary of the transformer. I'm going to turn it on, and it didn't do anything. And I guess I should hook the voltmeter up. I'm going to turn it on now, and we've got 16 so volts. I'm going to adjust this to its 15 volts. This is how I'll get 15 volts input to the little power supply board. It's not powered up yet, and I don't have the NMOS, the IRF 3205 installed. I just want to see if smoke comes out. Well, there's 9 volts there, but I mean, it shouldn't be. Well, that's interesting. Okay, well, missing the the MOSFET and missing the fan and thermistor, nothing smoked. As usual, I prepared a drilling template for the back panel and for the heatsink. My intention is to put two fans back here, blowing inward on the fins, with a grill on this side. So two grills, two fans. That amounts to drilling 8 holes for the fan in the heatsink. Then I'm going to mount, well, the inmost transistor on here. And then I'm going to mount, I think, this board on that, spaced far enough away, a comfortable distance away. Actually, depends on what kind of plastic spacers I have. Now, the thing about using a template is that you can make a drawing in some sort of drawing program, assuming you can do it to scale, get all the dimensions off the fans and whatnot, even off the printed circuit board documentation for these holes, which you could do just by putting some layout die on here and scribing. But if you want to change things, try to see how things fit. You can move them around in a drawing program. If you need to make 10 fans, you just draw one and then plop it down and so forth. I've tack soldered 3 pieces of flexible silicone insulated wire. The kit comes with a long piece of heat shrink tubing. I'm going to slide it on and shove it up. It would be fine, except that this red wire is bigger in diameter. I can feel it. Here are the standoffs that will hold the board. Here's 8 holes drilled in the back of the heatsink. I've just tie wrapped the 2 fans . Now, I thought I would do this just for testing, but I may just leave it that way. I decided just to mount the thermistor under one of the tie wraps. And I use this heat sink plaster. Now, I don't really like this because it's very hard to get the component back off. This is actually plaster. Get the bead in there, and I squeezed some heat sink compound in around the tie wrap and on both sides of the bead. So now I'll just wait until tomorrow. By tomorrow it should be set up and I can finish this. I've completed the thermistor. First thing I did when I powered it up, I adjusted this potentiometer so the fans are spinning slowly. Well, they're not spinning at all. Well, there we go. Fans are spinning slowly. I'm a little bit worried about this heat. The first thing I think I want to do is adjust the minimum current potentiometer. That's this fella right here. And the instructions for doing that are to set the current at minimum Adjust the output to 5 volts. Or thereabouts. So there we have 507. Then the instructions are to short the output of the power supply. Now I just want to make sure that it's less than a couple of hundred milliamps. Okay, and it is 300 milliamps. Now the instructions are to adjust it to minimum. I don't know how low I can do. I'm going to leave that at 20 milliamps. And now we're going to adjust it back to, well, we're pretty close. So until I get a more experience with this power supply, that's going to be good enough. Now let's see what kind of current we can get out of it shorted. So I can easily go over 5 amps. Well, I can go to 5.7. And a minimum of 21 milliamps. Now, ironically, this is not making any heat at all, of course. This is making a lot of heat. Because without any current flowing, this is dissipating very little. On the other hand, without any current flowing, the bus voltage and the transformer voltage is pretty high. The 12-volt fan needs to be regulated at 12 volts or less, so this fellow is dissipating the difference between 12 volts and the bus voltage. So I may actually just move this LM317 to this heat sink. The fan you hear is the dummy load. These fans appear to be spinning quite nicely. I've got it set for about 5 volts. The load is 2 ohms and reading about 2.5 amps. So I think I'll just leave it there. And we'll see what burns up first. I thought It's been running for 10 minutes or so. I'm going to take this thermocouple, I'm going to put it here. So it acts as if this is still heating up. And here, now this is degrees Fahrenheit. So I think I would feel a lot more comfortable if I moved this 3-terminal device over to the heatsink. The heatsink seems stabilized about 128, less than 130 Fahrenheit. Now I'm at 5 volts at about 2.5 amps. 5 amps is going to be a real test. After measuring the temperatures, and remember this was operating at about half design current, which means that the dissipation would at least double at full load. I've decided to rethink this project. I'm very unhappy with the amount of heat generated here. And because I intended to use a 12-volt supply inside the case, I think if I go ahead with this, I'll just get rid of this whole thing, power the fans at a constant speed, probably use a bigger heat sink, and maybe not more, but instead of 40 millimeter, I'll go to 50 millimeter fans. So I'm going to box this all up and study the schematic and see what I can do. If you enjoyed this series, or if I do another series, please give me a thumbs up, comment, ask me questions. Thank you.